This is video number 11. We're on page 19 in the back of your booklet. We are going to start with part 8 and then we'll go back and do part 7. So we're going to use solubility rules to identify the precipitate in each of the following reactions. So here's our solubility rules. And first, you want to always look at the anion. So phosphate is the anion in this compound. So when I look at my list, phosphate is here under insoluble, and then magnesium is the cation, and we're going to look to see is that an exception, and magnesium is not one of the exceptions, so this is going to be our precipitate. In number 2, we have silver sulfide. So I'm going to start by looking at sulfide on the list, and sulfide down here at the bottom. So that's under insoluble. Is silver one of these exceptions? It is not, and so silver sulfide is going to be my precipitate. Here we have barium sulfate. I'm going to go look for the sulfate, and if you look under soluble, sulfate is here. Is barium an exception? And if you look on the right, barium is an exception. So instead of being soluble, it is now insoluble. So this is my precipitate. Next is number 4. Let's start with the potassium nitrate. NO3 is nitrate, and so it's here in the list. It is soluble with no exception. So this is soluble. It is not our precipitate. There we have lead iodide, so let's go look for iodide. It is here. Iodide is soluble unless lead is an exception, and it is. There it is. So because that is an exception, this is our precipitate. It's insoluble. Finally, number 5 is we have sulfate there. And then ammonium. So there's sulfate. If you look to the right, ammonium is not an exception. So this is soluble. It's not our precipitate. And then this is missing a little 3 there. So we're going to look for the carbonate. Carbonate. And that's here under insoluble. Is magnesium an exception? Ammonium and alkali metals. Magnesium is not an alkali metal, so this is going to be our insoluble compound, which is the precipitate. So remember, everything that is insoluble is going to be our precipitate. Part 7 at the top of page 19 is going to be predicting products for combustion reactions. So this example is of methane CH4. So we write CH4. All combustions are going to be CXHY, some hydrocarbons. See, these are the hydrocarbons. You're always going to write plus O2 yields CO2 and H2O. So in number 1, they wrote CH4 plus O2 yields CO2 and H2O, and then they balance the equation with the coefficients. So let's do number 2. It's going to be C3H8 plus O2 yields CO2 and H2O. You will have to memorize to add O2 yields always the same two products, CO2 plus H2O. Now we can balance our equation, so I'm going to put my coefficients in the front. We have 3 carbons on the left, 1 carbon on the right, so I'm going to put a 3 here. We have 8 hydrogens on the left, and over here, 4 times 2 would make this 8. And now we're going to balance oxygens. There's 2 on the left, but on the right we have a total of 3 times 2 is 6 plus 4 equals 10. So because we have 10 oxygens on the right, over here, 5 times 2 is going to give me 10 oxygens on the left. And so this is balanced as 1, 5, 3, and 4. Let's look at number 3. We have C4H10. And then we're going to add O2, yield the same two products, CO2 and H2O. So now that I have my equation written, I'm going to balance my coefficients. We have 4 carbon on the left, 1 carbon on the right, so I'm going to need a 4 here. 10 hydrogens on the left, so on the right, 5 times 2 is 10 hydrogens on the right. Now the oxygens. We have 2 oxygens on the left, and we have a total of 4 times 2 is 8 plus 5 equals, and that's going to be 13. So when you have an odd number of oxygens on the right side, you're going to want to do these two things. We're going to put a 2 in this blank, and we're going to put this odd number right here in this blank. So you're going to get a 2 there. That's going to be a 13. And now I'm going to erase my carbon and hydrogen, my carbon dioxide coefficient and my water coefficient, and then I just have to fix those, change them, because I have a 2 here, so that's changed. So now we have 2 times 4 is 8 carbons, and then 2 times 10, so here I want 10 times 2, and that's going to help make it match. Number 4, we have C8H18 plus O2 yields CO2 plus H2O. Let's balance our coefficients. We have 8 carbon on the left, 8 carbon on the right, 18 hydrogens, so over here 9 times 2 is going to give me 18 on the right. Now the oxygens. You have 2 oxygens on the left. A total of 8 times 2 is 16 plus 9 is equal to 25. That is an odd number of oxygens, 25. So that means we have to do the following 2 things. We need a 2 here, and we're going to put that odd number, 25, in this blank right here. And now I just have to fix my carbon dioxide and my water. So I'm going to erase these because those are no longer going to work. We have 2 times 8 is 16 carbons, and then look, 2 times 18, so make this 18 times 2. And so it's 2, 25, 16, and 18. Number 5, C25H52 plus O2, go ahead and start writing my blanks, yields CO2 plus H2O. Okay, 25 carbons on the left, so 25 carbons on the right. We have 52 hydrogens on the left, so what times 52? It's going to be 26 times 2 is 52 hydrogens on the right. Now we'll balance oxygen. You have 2 on the left. A total of 25 times 2 is 50 plus 26 is equal to 76 oxygens on the right-hand side. 76 oxygens is what I need here. 38 times 2 is going to equal 76 oxygens on the left. And so this is going to be 1, 38, 25, and 26. Number 6, C2H2 plus O2 yields CO2 and H2O. On the left we have 2 carbons, so on the right, to fix it, I need to put a 2 here. Here we have 2 hydrogens, there we already have 2 hydrogens. On the left we have 2 oxygens, and on the right we have a total of 2 times 2 is 4, plus that 1 is equal to 5. That is an odd number of oxygens, and so we need to put a 2 here. We're going to put this odd number right here, and now I've got to fix these coefficients in order to match. So I have a total of 2 times 2 is 4 carbons, so put a 4 there. 2 times 2 for hydrogen, so I'm going to have 2 times 2 for hydrogen. So this is 2, 5, 4, and 2. 7 through 10 are special because the hydrocarbon involves an oxygen that we're going to have to take into account. So we're going to have C6H12O6 plus O2 yields CO2 and H2O. We have 6 carbons on the left, so I need 6 carbons on the right. 12 hydrogen on the left, so 6 times 2 is 12 hydrogen on the right. Now, oxygens. We have 6 plus 2 is 8 oxygens on the left. On the right, we have 6 times 2 is 12 plus 6 is equal to 18 oxygens. So over on the left-hand side, from the 18, I need to subtract these 6. So that gives me 12. I need this to be 12. So 6 times 2 is going to give me 12. 12 plus 6 equals 18. And so now I have a matching amount on both sides, and that'll be a coefficient of 1. Let's do the next one. C12H22O11 plus O2 yields CO2 and H2O. I have 12 carbon on the left, so we need 12 carbons on the right. 22 hydrogens on the left means I need 11 times 2 is 22. And now let's deal with our oxygens. There's 11 plus 2, which is 13 oxygens so far on the left. On the right, though, 12 times 2 is 24 plus 11 is equal to 35 oxygens on the left. So, let's see. Over here, 35 minus this 11 means that I need this to be 24. So, 12 times 2 will give me that 24. And so now I have 24 plus 11 equals 35 oxygens on the left side as well. So we have to add these plus these, and they have to match these plus these. Number 9, you have C2H5OH plus O2 yields CO2 and H2O. We have 2 carbons on the left, so we need 2 carbons on the right. Notice the hydrogens are separate. We've got to add them together. So you have 5 plus 1 is 6 hydrogens on the left. So 3 times 2 is 6 hydrogens on the right. And now let's do our oxygens. I'm going to add up the ones on the right first, which is really always what you should do. 2 times 2 is 4 plus 3 equals 7 oxygens on the right side. So I've got 1 there already. That means I need this to be 6. And so a 3 here will do that. 3 times 2 is 6 plus that 1 is 7 oxygens on the left side to match the 7 that are on the right side. So this is 1, 3, 2, 3. Put that one up there. Last one, we have C3H6O plus O2 yields CO2 and H2O. 3 carbons on the left, 3 carbons on the right, 6 hydrogen on the left, so 3 times 2 is 6 hydrogen on the right. And now let's add these oxygens. 3 times 2 is 6 plus 3 equals 9 oxygens on the right. I have 1 here plus an 8 would give me 9 on this side, so I need this to be 8. So 4 times 2 will give me that 8. And so that's 8 plus 1 equals 9. So I'm going to put a 1 here, and that's 1, 4, 3, and 3.